What's up, sports fans? Today we're talking about converse, inverse, and contrapositives. So you'll see above our learning target, I can write and determine truth value of the converse, inverse, and contrapositive of a conditional statement, as well as write and interpret biconditional statements. Got a few quick tips above. Remember, conditional statements read if P, then Q. We learned that in the last lesson. Then there's other statements right above. Those will make sense as we move throughout today's talk. Okay, we've learned previously that a conditional statement is an if-then statement and is in the form if P, then Q. P is our hypothesis, Q is our conclusion. So if the conditions of P are met, then the result is going to be Q. So there are three variations of the conditional statements we're going to talk about today. The first one is the converse. So it takes a conditional statement, it flips it around. It says if Q, then P. Generally speaking, if you have a conditional statement, the converse is going to be false. Sometimes it'll be true, and we'll talk about that in a little bit. The next variation is the inverse. The inverse says if not P, then not Q. So this is saying if the conditions of P are not met, then Q is not going to be the result. We call this the inverse. The last of these variations is called the contrapositive, kind of a big word, contrapositive, and it says if not Q, then not P. So if the original conclusion or the original outcome, the original results are not true, then the conditions are not met for P. The original hypothesis is not met. There are a few relationships that these statements, or the conditional statement and its variations have. So for instance, if the conditional statement is true, meaning that there are no counterexamples for it, then the contrapositive is also going to be true. They're logically equivalent statements. They have the same, what we call truth value, meaning if this one is true, then this one is also going to be true. Additionally, if the converse is true, then the inverse is also going to be true. They have the same truth value. So if the converse is true, inverse is true. Converse is false, inverse is false. Same is true for the original conditional statement. If it's true, contrapositive is true, and if it's false, the contrapositive is false. Okay, now we're going to talk about biconditional statements. A biconditional statement is one where the conditional statement is true. There are no counterexamples, as well as all three variations. This means that the converse is true, the inverse is true, and the contrapositive is true. This is kind of a tricky thing. We're going to go through an example here shortly, but generally speaking, if the conditional statement is true and the contrapositive is true, more than likely, more often than not, the inverse and the converse are both going to be false. But we're going to show you an example, or I'm going to show you an example where that's not the case. Okay, here's an example. Here's a conditional statement. If I am a part of Ridgefield High, then I am a sputter. True statement. There's no counterexamples to that. If you're a part of Ridgefield High, you're a sputter. That's our mascot. That's all there is to it, right? So let's check and see if the converse, inverse, and contrapositive are also true. Let's check out the truth values. So the converse says, if Q, then P. So that means if the conclusion is true, then the hypothesis is true. So if I am a sputter, then I am a part of Ridgefield High. Does that make sense? If I'm a sputter, then I'm a part of Ridgefield High? Well, yeah, it does. Believe it or not, there's no other school in the country, probably in the world, that identifies as a sputter, just us. So that is true. The converse is true. Now the inverse, if not P, then not Q. So if I am not a part of Ridgefield High, then I am not a sputter. That's true as well. So nobody else is a sputter except for those a part of Ridgefield High. Last one, contrapositive. If not Q, then not P. Let's check it out. So if I am not a sputter, then I am not a part of Ridgefield High. If I'm not a sputter, not a part of Ridgefield High. Yeah, that one adds up as well. So we would say that this one is a biconditional statement. Biconditional statement. And because it's a biconditional statement, we actually have another like if P then Q type of way that we write this out. We would say that P, if and only if Q. So P is true if and only if Q is true. And in the same way, Q is true if and only if P is Q. So they're dependent on one another. They're both true no matter what. Okay, our second and final example. If I am at school today, then today is a weekday. So when I mean at school, I mean attending school, not just here for a dance or a sporting event or something like that. So if I'm attending classes at school today, then today is a weekday. That's a true statement. We're not going to school on weekends. We don't do that. Now we don't even go to school, right? So if I'm at school today, then today is a weekday. Let's check out the converse, inverse, and contrapositive of this statement. So the converse is if Q, then P. So if today is a weekday, then I am at school today. That seems to be true, but I can find a counterexample for that. What about summer? What about holidays? Boom, counterexample, so that is not true. Inverse. It says if not P, then not Q. So if I am not at school today, then today is not a weekday. That's not necessarily true. Again, summer, holidays, there's weekdays where we don't go to school. Lastly, contrapositive. If not Q, then not P. Let's see if this is true. So if not Q, that's the second part, the conclusion. If today is not a weekday, then I am not at school today. Well, that's true, because we don't go to school on weekends. We only go to school on weekdays. So we can say that the conditional statement is true, the contrapositive of this statement is true, but the converse and the inverse both false. In addition to that, this is not a biconditional statement. Okay, so today we've talked about converse, inverse, contrapositive, and biconditional statements. Let me know if you have questions.